Yeah, cool. Now back to the business. So I hope you have a good dinner and we can now wake up with some very sensible topic. Actually, I will be talking about the code quality because this is the thing we should have in mind, and it's really very, very sensible. So my name is Anastasia Kazakova. I actually work for the company called JetBrains. So if you have any question about any other products, you can come to me and ask. So feel free. I will be, of course, showing some app code here as well. That's like obvious thing, but it's not the main focus. So the main idea is just to show you the set of tools for various steps that can help you make your code even better. So talking about the code quality, the first thing you have in mind is that when you're actually like doing, for example, the programming challenges like ACM, like your goal is to solve the problem as quicker as possible, send it to the system that checks it, and then got the answer that everything is correct, and forget about it, just start the new problem. That's how the things works when you're like playing with this programming in this kind of challenges. But when you come to the real world, you find out that the things just different. You can't throw the solution away just after you started it, just after you find out that it works, because most probably you'll have to support it, you have to maintain it, and the worst thing happens when you find out that it's not only you, but the big team around you, and they are all contributing to that solution. And that's a problem, because if you just don't keep this thing in mind, you'll come with a code that you need to throw away in a couple of days. And there were some stats, I don't remember where exactly, that usually the people are rewriting the project from scratch every 6 or 7 years. But at least you need to live these 6 or 7 years with your code. You need to earn money with that. So just do something so that you can actually provide some good solution for these 6 or 7 years until you really decide that, okay, let's throw everything away and start from scratch. So there is a lot of definitions of the code quality existing in the world, actually. Most of them consist of some words like the code quality is the code, like the good code is the code that is easy to understand, maintain, and use, and it actually works right. That is the very important thing, but not at the first place. So some people say that the high quality code is the code that meets the requirements, and that's not only the requirements about the code correctness, that's actually the requirements to the size of the team, to the size of the code, to the cost of the maintainability, and all the stuff around it. So there is some formal definition from Consortium of IT Software Quality. This is these 5 magic words, and the size word is actually quite important because the size should be suitable for this particular problem, for this solution, to maintain it and to keep it live. So there are actually quite a lot of words. So this can be the effort you spend on this solution, that could be the time that should be reasonable to earn some money on the market, but to be able to extend it. So, and like a lot of things. So what I like in person is that kind of definition. It's the WTFs divided per minutes. Because it's really important when some other person is coming to the team, how much time and these things he will pronounce while trying to understand what is going on in your just part of code. And the toughest thing actually happens when you're leaving the team and you're like, all the code is still left and there is a team who is supporting them, so there are some new people coming and they don't know what is happening there. And so if there is not so many WTFs, then your code is probably was good enough. And if it's too many, maybe you've done something wrong. So what problems could actually be there? There could be some logical problems. This is like some kind of real example that the Neil McIntosh from Microsoft was actually showing at the CPPCon this year. That's some real example from his code. So like hundreds of people were not noticing this problem, like that was the 2 consequent lines. And they were not understanding what is going on. And that's actually the problem, is that there is an if statement that never happens. And all the code there, you can just throw it away. But the people were just maintaining the code. They were still adding some lines to this if statement. And they were like, not the business you should do, because it's just on the code that never happens. So there could be more complicated examples like this one. This is actually just the same. The if statement is still not happening here, like because the value that was assigned before. That's a little bit more difficult to notice that, but still you can. And they could be also these things. You know, the key value coding is perfect in Objective-C until you use the key coding values that are not existing. So you could just get the runtime problem, runtime error. The compiler couldn't tell you before about that, and just you are trying to figure out what's actually happening there. So I believe everyone have heard about that. So this is the GOTO FAIL problem introduced in the SSL protocol by Apple. So there was just simply a doubled line GOTO FAIL. And because of this doubled line, all the code that was after this second line just became unreachable. And they just somehow missed that. So they fixed it in I believe in a couple of days or a week. I don't remember exactly how long it took them actually. But because the code is open, we can just see what was going there. And it would be good if we could notice this problem in advance and to prevent them somehow. So there are quite a lot of problems that could be happening here. So this is not even the full list. This is the small part of the list that could be happening there. So there could be some dead code. They could be copy-paste. We all do copy-paste, I believe. And everyone is telling us that it's bad. And it's bad, of course. But I believe we'll do this for ages. There could be some problems with hiding the scope, and you don't understand what is actually going in there because you come to some new part of code, you start encoding something, you're hiding the scope of some upper variable or property, and you just do not notice that, and that's a problem. Too much happening at one place is also a big problem because if it is, that means that you are trying to push everything and to keep everything in one place, and sooner or later you get a problem in that very place. So there are some bad coding practices, there are patterns violation. The important thing here is code style inconsistency actually, because if everyone in the team uses the different code style guideline, that actually sooner or later you come to the situation that you don't understand what other people are providing this code, what they were thinking about. Because if you have the similar code style, you got used to some similar things. You got used that this is actually implemented in that way. It doesn't only consist of the spaces or the new lines or the wrappings. It's also about the naming of the things, like naming of the variables or types, or how many lines do you prefer to have in one method. This also matters actually. So what we actually have to do, it could be we could simply find out with some solution that is not the silver bullet, but at least to understand what we need to do. What we need to do is first to follow the code style when we're actually writing the code. We should probably generate some code, at least some general and quite often used pieces, because if you do that, you probably do that in the similar style every time, because it's just the auto-generated code. Because you could be a guru in programming, but when writing the similar piece of code for hundreds of times, next time you will be doing it in the other way. And that's good for you because you're actually evolving, but that's not good for those who are supporting the code, for the code base. Static analysis, this is the most important of all these five. So the perfect thing is that the static analysis is running just on the fly. That's the thing you probably dreaming about, because you could run it or you could just forget about it if it's just a standalone tool. And the good thing is when you can just see what's going on with the static analysis running more or less at the same time while you're coding. The static analysis just shows you that something is going wrong. After that, you have actually to fix it. Either you're doing some things manually or refactoring, and then you have to actually run some kind of test just to be sure that you haven't broken anything while trying to reach the better quality, because the correctness is still staying there in the list. So, but that's all good until you come to the understanding that you need a tool for that. And that was actually the thing that the Björn Straustrup was talking this year at CPPCon. You know, C++ language is 30 years old, but the guys in this language are still dreaming about tools. And they're still saying that we need tools. The whole conference in Bellevue were actually dedicated to the static analysis and to the tools. It was the main topic for the lead language that's actually 30 years old. Let's start thinking for iOS, like for Objective-C and for Swift, a little bit in advance, not after the 30 years. So we need tools, that's obvious, but where to get them? So what I'm actually going to show here is to go through all these steps, like all this solution, and trying to show what tools we actually have in our current environment. And maybe later we could come with more. So I was actually doing the very similar talk a year ago, and while preparing to this year, I found out quite a lot of new tools happening, especially for Swift, and that's great. Actually, that means that the community thinks about that, and we got new things in the family. So let's see what we got actually. So starting with the code style. So first of all, when talking about the code style, what you need to have is actually, you need some guidelines. Because you could have tools, but you need to know what to check actually. So there are, of course, the Apple coding style guidelines for Reki code, but they are maybe not so wide, they're not so detailed. There are very good Ray Vanderlee guidelines placed on the GitHub. You can find the link. The only thing you should take in mind with the Ray Vanderlee guidelines that they are more for representation of the code, because their main goal were to produce some guidelines for the code to be presented correctly in their courses, in their workshops, and all the stuff around. So they are very good, but they are more for like making the code readable. The second good thing is the GitHub guidelines. They're actually very, very popular, and a lot of tools currently refer to these guidelines. There are actually more. So for example, the Spotify guidelines, they're like every big company tried to issue some guidelines. They're using some kind of publicly and to share them with all the community. But the guidelines means nothing without the tool. Because if you just have like, you know, the piece of paper with the guideline, you will just forget about it in the minutes you are starting thinking about the real problem in your code. So if talking about the actual tools, we have the Clang format for sure. This is like the basic tool we have. It's standalone. It provides you the possibility to get some integration. There is this very famous plugin for Xcode called Clang format Xcode. And the thing that I really like about this plugin is actually it allows you not just to run the tool separately, that you can just forget or not, but it allows you to enable the reformatting on just saving the file. So while you're saving, actually something is happening just in the background. And because you have to save the file in Xcode, more or less, you will be like running this reformat automatically. So it checks for some indents, braces, breaks, and all the stuff around. The only problem that unfortunately is not fixed yet is that it's for Objective-C. So there are quite, I believe, few requests about the Swift support in Clang format. I'm pretty sure they still haven't come out with something, but they should come, because that's like the thing everyone asks about. So if coming to the actual plugin and how it works, the thing that I like about it, so this is like the menu that comes when you just install the plugin. So there is some predefined code styles you can select, or you could just configure your own with some rules that you can load, because it's just the usual Clang format. And there is like a big documentation on the Clang part of the site, so when you can find how to define the actual rules and what is possible. So you can like format the selected text or selected files, or this is the thing I was talking before, this enable format and save. That's, I think, the most useful part of this plugin actually, that suggests you to run actually reformatting on every save in the file. So there are quite a lot of other tools. Most of the companies are actually, as far as I see now, they try to run the code style checks on the pre-commit hooks. And there are quite a lot of tools doing that on the GitHub, so you can find quite a lot. And so like the Space Commander, that's also using the Clang format. There is Aussie style, there is Swift format, some more actually. There are like quite a lot of them, I should say. So there are some checks for the code style on SwiftLint. I will be talking about the SwiftLint later as well. So, and of course, because, you know, I'm from the JetBrains company, I couldn't just go without that. And this is the app code and the code style checks in the app code. So what we have in the app code, we have these separate settings for C, C++, Objective-C, and Swift. So you could just different Objective-C from Swift in these settings. There are like, I believe, hundreds of them, so you can see quite a lot of tabs on the screenshot. So there are like tabs and indents, how to configure them. There are spaces, there are wrapping, there are blank lines, there are like code generation templates, and much more. So just not to be lost in them, we've added this nice preview thing. If you haven't seen this before, just know that if you change something in the settings, the actual change will be highlighted. So in this preview, so you could actually find out what this option actually means. Because I believe sometimes we're not very cool at naming so the settings, but the preview should actually help us with that. So the good thing that we tried to, and we actually do, and that's the main thing about code style in AppCode, is actually we do all these checks and all these things on the fly. That means while you are typing, the code is reformatted automatically. So you just like set all the rules, then just start typing, and the AppCode actually helps you follow them. So there is, of course, the reformat action if you come to some like piece of code that is not formatted correctly. There's, in some new versions, there were a lot of things added, like keep the formatting that was for that particular file, like not to reformat the libraries that have the different style, and all the things around. But so the main idea is for us is to have on-the-fly code style support. So there are also the possibility to reformat the code in a commit stage, so just before committing to the version control system. You probably know that AppCode has a version control system integration, and that there is the unified interface, and in this interface you could actually check the option to reformat the code and commit. So okay, that was about the code style, and now let's come to the code generation. So as I said before, it's good to have some code generated automatically, because that means that you are doing it in the same way every time. So the easiest thing is that you create a file from Xcode template and has some hooks for you generated, so you more or less remember that you have to do them, or more or less know what is going on there. There are also the code snippets for Objective-C and Swift, not so many of them, but you still could add some of the snippets you prefer, so that's just up to you, and I really encourage you to add the pieces of code that you do quite often to the snippets, and to share the snippets with the whole team so that all of you are doing like these things in the same style. There is a very nice option in the code generation, talking about the code generation, nice option in code completion in Xcode that came, I believe, quite recently, that when you start just typing the name of the parent method, it just completes with the like whole signature there, so just some kind of an implement override built into the code completion. That is very nice, that is cool. There were some third-party tools for code generation available on GitHub, but as far as this now, unfortunately, somehow they are more or less dead, so they are not evolving currently, at least in the latest year. I don't know why, so probably the people like heard that everyone is done already, so who knows. So, and of course, common to the AppCode code generation features, so we have this generate menu. So if you've ever tried AppCode, you can find it, just press the command, then you will see the menu. So every line of code on this screenshot just was auto-generated. So I haven't like written any symbol on this screenshot. So everything was generated automatically, so you could select some like copy with zone or is equal and hash or description. You just need to put what properties you are actually going to use inside these generated methods. So the generate menu, and this is about it. So the AppCode also had the live templates that's the same as the code snippets. So we just call them the other way. There is also override implement and the file templates as well. So if you are not creating the file from the Xcode template, if you do, like the usual template will be created as in the Xcode. If you like if you use something different, you can actually configure the file template for your actual file. Maybe it's some, I don't know, some structure that you are going to use in many, many files. You can do that as well. And the very nice tiny addition that I like to the code generation is that the things that we call create from usage is actually when you start using something, you can then generate it, because when you start using, you actually got the red highlighting that these things doesn't exist, like some local variable, for example. And if you press the Alt-Enter, you could get the options how to resolve the problem. Either you would like to create a local variable or a property or a global variable or whatever you want. So this is like the code generation. So all these templates are also configurable for the code generation, so you could find them in settings and configure in the way you want. So, and you could actually share them with the team, so you could just export the settings and import them to the team, to every member of your team, or you could just submit this particular file from the app code projects to the version control system, and when the other part of the team will be just taking the project from the version control, they could take this file as well and get all these templates on board. So this could be useful if you have some templates that are really happening quite often through the whole solution, just to have them in a similar way. So talking about the code analysis, so this is the third part. First of all, you again need to have some guidelines, because without the guidelines you don't know where to move. Then you need some settings that will help you to configure these actual guidelines, and it will be actually good to have on-the-fly mode for the code analysis, because if you just have a tool that could check some things, it's great, but sometimes you just forget when you are in a rush, like you have a release, you have everything like firing up, so just if the tool will be checking it for you on the fly and just forcing you to fix some things, or at least forcing some notifications for you, then probably it will be easier. And the quick fixes, like when it's not usually enough just to warn you that something is going wrong, it's good to show you what can be done actually. So talking about the static analysis tools, there is of course the Clang analyzer that is open source, and it's like a part of the Clang project. It's integrated smoothly into the Xcode. You could just see all the warnings here. The only thing I actually warn you is just don't forget that a lot of things are switched off by default there, so you have to switch on quite a lot of warnings to get the whole picture. So the good advice here is maybe to switch everything on, or at least nearly everything on, but I believe not all of us are actually doing that. So, but it provides quite good basic checks, some dead codes analyzation, and some API checks, and so just more or less okay. But the tools that I really like is the pair of tools. One is called Oscillint and one is called SwiftLint. So they are very similar in terms that they are mostly somehow metric-based, so especially the tool for Objective-C. So it's not only checks these like usual things that you got used to the Clang analyzer, but it has some metric-based checks, like you could set the maximum length of the method in lines or the maximum minimum length of the variable. Like for example, like to prevent some cases when the variable is called IK just in, and it's not just the iteration or something, but it's some valuable name, so you should not do that. And for that, there are also some checks, so there are some bad practices that you can check as well with the tool. And the good thing is that the rules are dynamic, so you could just switch on or switch off some rules. You could just even compile your own rule and load it. It's also integrated with the Clang analyzer, so it provides the same thing as a Clang analyzer and some more things on top. And the great thing is that it can be used inside the Xcode in the same way as the Clang analyzer. That means that if you run the actual tool on the build phase, as a, like run the script, and it will provide the output that you can just then, for Oscillint you should do some more things with set there. For SwiftLint it just integrates smoothly, so you just get all the warnings as you see them in the Clang analyzer, just highlighted the, like you come to the actual string and you see what particular problem is happening there. So the SwiftLint is very similar, so it's actually for Swift, as you could just get from the name. So it tries to follow the GitHub rules, like the GitHub guidelines for the Swift language. It's actually in the very beginning, so I believe they have implemented something about 15 rules up to that moment, so not that much actually. There are good plans, like they are thinking about adding some more style checks in terms of spaces and news lines. They are thinking about adding some let over var rules or struct over classes rules, and some more things like working with optionals, like to force you not to use the unwrapping and to force you to specify access control things. So all the things that could make your code like better in terms of understanding the language and using the new language. So you could actually contribute to this thing, and the great thing that I really liked about the SwiftLint is that all the rules are actually implemented in Swift. So if you're like starting learning Swift, it's a good thing just from one side just to learn some proper static analysis and some guidelines rules for Swift, and from the other hand just to practice the Swift language. They're quite nice, so the rules are like that, very simple, and they are like very beautiful in terms of Swift code. Maybe that's why they have not so many of them, because they're polishing them quite nicely. But I believe they have a big future because the tool looks nice. So what I talked before, like you can run it as a run script phase in Xcode, for example, and then you get something like that. So you just see the rules, all these problems highlighted in the actual code. So just a few examples from the Swift lint. So for example, they can now currently check for the to-do or fixed me left in your code. So if you have forgotten something, they could check and point to that. They could actually point some name format violations for the types and for variables. So by default, like the variable name should start with the lowercase and the type name should start with the uppercase. And they have some basic code style checks like the trailing white spaces or some more things about the white spaces. So you could change the severity of the rules, so you can make them either errors or warnings, and just to run them in that style in your build, and you will see everything in the way you just got used to in Xcode, like all these warnings highlighted. So, and of course, talking about static analysis, there is the app code as well. So we are a little bit keen on all these things with static analysis. We like running it, we like doing these things. So we also have the integration with the Clang analyzer. So all the things that are coming from Clang are there on board. But apart from that, we have 60, we call it inspections, all these rules. So 60 inspections for Objective-C and around 40 for C and C++. Currently, no rules for Swift, but I hope they will be coming shortly. So there is the on-the-fly mode. That means that while you're typing the actual code, the IDE analyzes the code and shows you the potential problems you could have. There is also the severity levels that you can configure, just either to treat the problem as warning or error or whatever you want. So, and this profile you also could load to the version control system or share with the team just to be on the same wave. So, apart from the usual thing that Clang Analyzer does, we've implemented a couple of complicated cases. So starting from the very simple hiding of the local scope, for example, that could happen if you just forget that you have the instance name with the same name as you're trying to use for the local variable, and coming to more complicated cases like the possibly undefined key path in the key value coding. So if the IDE finds out that probably this is not the key path that exists in your project, it will try to warn you. The good thing is that it's not only the warning. If you press the Alt-Enter, you could get the possible solutions. So, for example, for hiding the hiding the scope of the instance variable, you can get like to reuse the instance variable or to change the name. For the undefined key path, you can just get the suggestion to create the property of that name, or just to think about renaming the code you're actually typing. For the key value problem, there is actually one more hint. The app code actually highlights the things in different ways. So if it's just a string, it will be highlighted as a string. And if it's a valid key name, it will be highlighted in another way. So there is another hint that's actually helping you to cope with the problem. And there is also these things like the more than literal syntax checks. And I mentioned it here just to talk about the bulk mode, because what you can do in app code, you can run the particular inspection for the whole project or any scope you just configure. Just run inspection by name, select the scope, and in that scope, for example, the whole project, like I got some old project and it uses only the old style syntax, I just run this inspection for the whole project, then get the whole list and press Alt-Enter and fix them all at once. That's what the bulk mode. Of course, the quick fixes exist not for every bulk mode, like not for every inspection, because some inspection need at least some typing from your side. They could not be fixed in the bulk mode, but at least for what we can, we've tried to provide this thing. More profound things also include some checks for non-localized things, like if you have something non-localized in your code and you're trying to use that, the app code will highlight that the thing is not localized and suggest you actually, with a quick fix, to provide the localization. So either it's the whole localization missing, or if you're just missing the localization for one particular language, it will be just showing you that here. And another great thing is the actual data flow analysis. On the screenshot on the right, you can find out the example of the C++ code with the actual data flow analysis running. So what's happening there is actually, you can see the unreachable code warning, and it's there because just in the switch case, that was the first one, you assigned the C variable to red, blue, or green, and you never used another color. And so if to analyze the data flow, you could find out that the yellow or any other color could not just be there, and that's why the code is unreachable. And that's actually is very important because it's the data flow. You could not check this with the compiler. For this, you need actually to run through the whole execution flow somehow and to understand there. So you could either run your actual program or just find the tool that could do this for you, like trying to analyze the data flow. And that's what we do for app code. We actually do the data flow analysis. So coming to that nice actual example, so let me find it with the GOTO FAIL. I believe there are like at least 3 ways to find the problem in this code. So first of all, if you have the code style checks working on the fly, after the first, let's imagine first that we are trying, typing this manually. So if you just put the enter after the first GOTO FAIL line, the indent should go to the left. So it should not be just after the GOTO FAIL. And this actually helps us to notice that that's not the correct way of doing that. So another thing is the static analysis, of course. So if you have the proper static analysis working here on the fly, you have the Clang analyzer checks switched on, or you have just the app code running the analysis for you. You could find that the code is unreachable, the code after the second GOTO FAIL line. And there is also a third way. So if coming to app code actually, so there is that nice thing that when you try to commit your code actually, so there were some assumptions, maybe you've heard about them, that the GOTO FAIL was introduced on the merge state. And if it's really so, it's sometimes hard to notice that something went that wrong when you're trying actually to merge the code. So that means that, okay, so if that's the case, in app code, you can actually, while committing your code to the version control system, select a couple of things. You could select the reformat the code, or you could optimize the imports, perform the code analysis, and that's actually what could help you. So if you perform the code analysis at that stage, you could just catch the problem with unreachable code here. So you see that we do some more. So we check in the to-dos just to check that you haven't left something in your code undone. So yeah, that's how it looks like. So another thing is refactoring. So of course there are Xcode refactorings like this list. The only bad thing about Xcode, they're still working only for Objective-C and C. I believe this is the most popular screenshot from Xcode for the last year. The people are asking about the Swift refactoring. So we've done actually one refactoring for Swift in app code. That's the rename. We still hope to get more, but we're a little bit stuck with the Swift version 2 that came out recently and mixed the plans. But we still want to provide more. Hopefully will come soon. So apart from the usual list for Objective-C, we have this change signature thing that is very nice in terms of that if you're adding, for example, some parameter to your method, it updates all the usages with some default value, at least try some default value for this parameter. If you're for example, swapping changing the order of parameters, it will change the order for all the usages and all that stuff around. So there is extract nearly everything variable, constant, or whatever you want, and it will be checking for the duplicates. While extracting the variable, you can just change all the occurrences at once with this refactoring. So there were some extra projects on GitHub, like Refactorial, for doing some refactorings, mostly for Objective-C. I haven't seen anything for Swift currently. I believe the people are, I don't know, maybe a little bit afraid for doing refactoring for Swift, but That's not that tough. Believe us, we can do that. I believe everyone can do that. So, but still, yeah, currently we're a little bit limited in terms of the tools for refactoring, unfortunately. So, and the last thing that we should mention here is actually the unit testing thing. So there is the basic XC test. I think we all are using it. But there are actually more. So there is some nice things like Kiwi for behavior-driven development. For Objective-C, there is Google Test for C and C++. There is some tools already for Swift, like the quick and nimble frameworks that are appearing. And I'm very happy that the speed with which these frameworks are appearing is like quite big now. So we have a lot of things coming and happening in the family. And that's actually good because when it's a little bit boring to be limited to one framework, I believe. So adding one thing about the app code and the unit testing, I should point here that app code currently supports the XC test, Kiwi, and Google test. And so there is some nice code generation for each particular framework, so you can generate the methods for each framework. It depends on in which context you actually call this command, then you will get these things to be generated appropriately. So, and yeah, I think this is mainly it. So just a small summary. This is the things you have to check on the left, and this is some of the tools I was talking before on the right, and I think that these tools are really very important in the EIS world. I really hope for more tools coming for Swift in the future, because we all are starting learning the Swift, and sooner or later we come to understanding that we need some code analysis tools for Swift as well, and the people will start writing them. So yeah, that's it. Thanks for listening. If you have any questions, I think we have some small time for me to answer them.